We'll summarize here properties of the inverse functions. So let's look at the diagram. We are starting with function f, and the function f assigns to the value x, value y, and the function f inverse does opposite, assigns to the value y, the value of x. So y is the value of function f at x, and x is the value of function f inverse at y. Therefore, we have the first property. If the y is equal f of x, then x is equal f inverse of y. And equivalently, after switching x and y to get more traditional notation, we'll say that y is equal f inverse of x if x is equal f of y. Second property tells us relation between domains and the ranges. Again, the diagram explains that relationship pretty well. Domain of the function f inverse is the range of the function f, and the range of the function f inverse, the set of outputs, is the domain of the function f. Property number 3 is really definition of the inverse functions. So composition of f and f inverse is identity function. What does that mean is that the function f inverse undoes what function f did. So let's look at that diagram here. If we start with x equal 1, function f acts on 1 and returns as the output a. Function f inverse takes that a and assigns to this the value 1. So we have a circle. We start with 1, and by applying one function after the other, we'll get to the same 1. It doesn't matter whether I start on the left or on the right. If I start with b and apply f inverse, I will end up at 2. And now if I apply f to that 2, I will get b. So the property 3 is not only definition, but clearly indicates that relationship between the f and f inverse. F inverse undoes what function f do. And the last property is very important as far as graphs are concerned. We'll say that the graphs of the function f and f inverse are symmetric with respect to the line yx. Why is that? Now, if we recall the graph of the function f, we remember that the graph of any function is the set of the pairs input and output, so x and y. This point is on a graph of the function f. Now, if I'm looking at the f inverse, I'm also looking at the inputs and outputs, but for function f inverse, y becomes the input and x is the output. Function f inverse switches inputs with outputs. So if the point x and y is on the graph of the function f, then the point yx will be on the graph of the function f inverse. Points xy and yx are symmetric with respect to the line y equal x, and therefore the graphs of the function f and f inverse are symmetric with respect to the line y equal x.